ఇది నువ్వు వాడుతున్నావా?
Good morning, all.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Morning, good morning. Am I audible?
Audible,
Yes,
sir.
sir.
Yes, sir.
In the last class, we were dealing with Newton's laws, and that too, we have done problems on change in momentum. No? Am I right?
Yes, sir.
Change in momentum by time taken is the average force. Right. What is the last problem? The iron ball falls. That one only, no? Right. Come back to this. See, did you ever see water pipes are there? See, water pipes. They'll be using on pipes like that. Okay. So this is a liquid that is flowing through this. The cross-sectional area of the pipe is given. Liquid of density rho is flowing with speed v. Through a pipe of cross-sectional area capital A. The pipe is bent into the shape వస్తున్నాడు వస్తున్నాడు వస్తున్నాడు
వస్తున్నాం.
what force should be exerted Understand the question?
No, sir. Can you please explain?
No, you wrote the question I'm saying. I'll explain the question. Wait. See, when the
Yes.
pipe is going like this, you can see this is momentum I cap. What is the momentum of any fluid particle? Minus J. Do you agree with this? That
Yes, sir.
means here fluid changes what?
Direction.
Direction of motion with constant speed. What will happen? There is a change in momentum, no? Do you agree with this?
Agree, sir.
Therefore, fluid means a liquid. Okay, what anything which flows is called fluid, because of which fluid momentum changes. Any doubt is there? Hello?
No, sir. Okay.
Clear? So here, so what we can say, force on liquid exerted by whom is what?
Minus. Minus of
Change
force.
in first, no, you said first change in linear momentum of liquid by delta T. Okay, this is final momentum minus what is the final linear momentum? This already we have. What is this? Remember? Hello?
Yes, sir.
till here.
Yes, sir.
Yes, sir, followed.
Sir? Sir?
Tell one.
Sir, in the question, can I explain that last line, sir? What force should be exerted
On the pipe, force on the pipe is nothing but equal and opposite to force on the liquid, no?
No, sir, I'm not understanding that last word, sir, to keep it fixed.
Yes, one, that one. First we want, one thing you understood, no? Force on pipe. This you know, no?
Yes, sir.
That means force on pipe means there are only two things here. See, always observe. What are the two things available here? One is liquid. The other is pipe. Only two things. So force on pipe, force on liquid by the pipe, no?
Yes, sir. Yes, sir.
So we'll first find force on the liquid by pipe because change in amount of liquid is known, no? Using this force on pipe by liquid is equal to minus of force on liquid by pipe. So this is a minus of do you agree with this?
Yes, sir.
Yes, sir.
Now you can see what is the direction of this force. If you observe this carefully, I plus j rho a v square, see the force has two things. What are those? One is along I cap. The other one is along,
Minus j cap.
no, j cap. So what should be the net force then? So net force should be in which direction?
Diagonal.
Now this force is on the corner only, no?
Yes, sir.
That means on the pipe, the situation is there is a force on the corner. It is at the bend only, no?
Yes, sir.
That is what he is asking. You can see practically also in your home, if there is any pipe that is bent, here they will be keeping one clamp. If you observe, you can see now also.
Yes, sir.
The clamp only exerts that force. Understood what I am saying?
Yes, sir. Understood.
Shall we turn the page?
No,
1
sir.
minute,
Please
sir.
wait, sir. 1 minute.
So one method you found to find force is change in momentum by time taken. Shall I turn?
Yes, sir.
1 minute, 1 minute.
1 minute.
See here, how to solve problems of this is what we call it as free body diagram. A system means interconnection of many bodies. Okay, so here show is show okay, show forces here do not show understood this? Hello.
Yes, sir. Understood, sir.
See, for example, this is surface, and my body is here. Now you can see that this is mg. This mg is the actual reaction for this. Understood this or not? Clear?
Yes, sir, clear.
This is earth, remember. So this is table, for example. This is the normal reaction on the table, this is the normal reaction. So these two are action reaction. These two are action reaction. Followed?
Yes, sir. Follow.
Or mark or choose coordinate system. So be careful, this is lifelong analysis for you throughout engineering. Mark and choose or choose coordinate axis. Next step. Okay. Then resolve forces along axis. Okay. This sum of, see, you'll understand this better if I explain it some problem. Equals till here you follow the steps actually. Here
Sir, what is that coordinate axis, sir? I can check that.
X and Y include pseudo force. Understood the steps? I'll explain one by one. Clear?
Yes, sir.
Shall I turn this?
1 minute, sir.
1 minute, sir, 1 minute. Sir, what is the meaning of the second point, sir? Do not get forces exerted by this body on another ball.
Yes, ma'am. You're showing the forces of this. On this, what are the forces? One is exerted
Yeah,
by
right.
Earth, the other one this. Okay, this also exerts on this. Do not show that. Again, don't show another energy, I'm saying. This is exerted
Yes, sir.
on Earth. This is exerted on the surface.
So we should show the forces of only one particle.
Forces on the particle. I did not say one particle. Forces acting on, not by.
Yes, sir. Now understood.
Okay.
Yes, sir, understood.
Shall I turn this?
1 minute. Sir.
Over?
Yes, sir, completed.
Completed, sir.
See, suppose this is an elevator or a lift. So this is a man. This elevator is going. This is the acceleration. This is the ground. Now I am choosing two things. One observer here, ground observer. Okay, let us see. He draws the free body diagram. Mass is M. Free body diagram of person. On him, this floor will exert one force. Do you agree with this? Okay.
Yes, sir.
And he has his own weight. Here, remember that with respect to whom? O1, who is who? Non-accelerating. You have to specify that. Does he have any acceleration? There is no acceleration. So should I show any pseudo force?
No need, sir.
No need of pseudo force.
Sir, lift. Sort
No,
Sorry.
I am sure for that is the reason why I am for here. Do I need to do any show force? No.
No, sir. With respect of
So-
observer, no pseudo force.
No, I am talking only with one. I am not talking with anything. Okay. This fellow, this is the acceleration of man with respect to O1 we should take. So this fellow will feel that that fellow is going up with an acceleration upward. Do you agree with this? Hello.
Yes, sir.
Yes, sir.
So I have separated the body. I have shown the forces. Now I am taking this as the y-axis or positive direction. Now the next step is sum of the forces. What are the sum? Upward is positive, downward is negative. After summing up what I said must be equal to mass of the body into acceleration of body with respect to O1. Do you agree with this? That is what I told now. Boys?
Yes, sir.
M into this is A. So what is the normal ESG you got? Understood this? Hello.
Sir.
Shall I go ahead?
Sir, 1 minute, sir.
Sir.
Understood this?
Sir.
Tell.
That is force into acceleration, right? That first step.
Force into acceleration.
Sir, what did you do in
Mass
that first step, sir? That's
Huh?
mass into acceleration, sir.
Yes.
Sir,
Not
mass
force
is
into.
acceleration is zero now, sir, for that particle O1.
This is what you are talking when mass M with respect to O1. What this fellow thinks his body is going, what he measures.
It moves
Hello?
upward. It moves
Ah,
upward.
that's what same thing I showed. For O1, you are standing in the ground, it is going up. What do you observe?
It's moving, sir. It's moving upward.
Acceleration upward A only, no?
Yes, sir.
Jet. Switchboard. Opposite switch. Sale was chemical. Shall I do? Go ahead. Boys?
Sir.
Yes, sir.
Yes, sir.
Right. Now, there is another observer here, O2. Now you can see both are moving now. Agreed. So O2, acceleration of O2. Now we'll show the same thing. FBD of person with respect to whom? With respect to O2. O2 is accelerating now.
Yes, sir.
Sir.
Is accelerating with respect to ground now. Acceleration of O2 with respect to ground is nothing but A upward, no?
A.
Understood this? Any doubt is there? Now show
No,
the
sir.
person. If you show the forces, mg and n is okay. Anything else is there? That's all.
Pseudo force.
Pseudo force in which direction?
Down. Yes, sir. Down.
It is the pseudo force. M into acceleration of observer with respect to ground. M into A. This is only pseudo.
Minus acceleration of observer, no, sir.
Minus means opposite, no? Acceleration observer upward. Where you will show direction already shown, no?
Yes, sir. Yes,
Minus
sir.
indicates opposite, that's all. Agreed. Then
Yes, sir.
see. Then if we take this as upward, some of the forces ఇప్పుడు చూడు రుద్దుకోమా ఇది equals mass into acceleration of whom? Acceleration of man with respect to O2. Till here, any doubt is there? Boys? Hello?
No doubt, sir.
No, sir.
Till here, agreed?
Yes, sir.
Now, can you tell what is the acceleration? For O2, see, actually, you can directly read, I am explaining. Acceleration of M with O2 is acceleration of M with respect to O1 minus acceleration of O2 with respect to O1. No? Now you can see both are having upward acceleration only, no? It's nothing
Yes,
but
sir.
zero only, no? See,
Yes, sir.
you are sitting in the front, in the car, driver is also sitting. For you, car driver is not accelerating, no? For you, is the car driver accelerating?
No, sir.
No, sir.
A person on the ground, he'll observe that car driver is moving away. That means he's accelerating now.
Yes,
Answer,
sir.
man. Agreed or not?
Sir.
Yes, sir.
That means for O2, this fellow has no acceleration. So here, this is nothing but zero. So what is that you got? Now you can see that are both the same or different? Both of these are
Same,
same
sir.
or same? That means you can solve a problem with respect to ground, that is inertial or non-inertial. Anyway, you should get the same result. But means frame of observation is changed, you should not get a different answer. Understood this? This analysis is what we call it as free body diagram. Any doubt is that till here?
No doubt, sir.
Understood this? What is free body diagram?
Yes, sir.
Yes, sir.
Thing is, what is the frame of reference you are seeing, that is important. There only you'll take pseudo force or not. That decides. Completed?
Yes, sir. Complete.
Return the page.
Yes, sir. Yes, sir.
Right. Now let us continue this discussion. This is only the Newton's last one. Free body diagram is only the Newton's laws. Change in momentum you have already seen. Only two things are there here. So now the conceptual part is clear. Now there are three strings here. This is one string, this is the other string, this is the other string. These are knotted here. This is 300 Newton. Okay. We are supposed to find the tension in each string. See, here all three strings are interconnected by what is this called? Knot, no?
Yes, sir.
Now we'll draw the free body diagram of knot. Okay. Follow this. If nothing is mentioned, it is understood that with respect to inertial frame only. Remember that whenever we are not mentioning anything with respect to home, it is understood that it is with respect to ground. Ground is nothing but inertial frame only, no?
Yes, sir.
Yes, sir.
So here, specifically it is not mentioned. Ground only, no?
Yes, sir.
Hello.
Yes, sir.
Now, let us see this. I'll show here only because now you have some experience now. This knot is here now. These are two string, three strings. First string, second string, third string. Now let us show the forces acting on this. Now can you tell tension T1, this knot is being pulled by the rope now. This is T1 now. This knot
Yes,
is
sir.
being pulled like this or not. Tension is always a pulling force now. This is T3
Yes,
now.
sir.
Any doubt is that?
No, sir.
Okay, he has given this is 37. Understood it? Now you can see that knot is having negligible mass. That's why we are not showing mg. Clear? Hello?
Yes, sir. Yes,
Then
sir.
after that, what we said meant resolve. Say this is one axis, this is other axis. Positive, positive. Right? Now this is 37 now. If this is 37, what will be this? 37 only, no? So resolve this. What is this? T1 cos 37. Like this, what you have? These are no need because along x and y only, no? After that, what you have? If we take this as the x-axis, this is the y-axis. Sum of the forces along x-axis is nothing but mass into acceleration. So what are the x-axis forces, man?
T1 cos 37 degrees minus T2.
With respect to ground, it is 0, no? Agreed?
Sir.
T2.
Minus T2.
This is 4 by 5. Okay. Similarly, we can apply follow this. Any doubt is that till here?
No, sir.
Why?
I have one
No.
doubt, sir.
What is
Sir,
it?
this knot is being pulled by the string. Similarly, knot will pull the string, no, sir.
But
Backward.
I don't need that, no. String pulls the knot, only those forces I need. There will be other forces I don't require, I'm not showing.
Okay,
That's
sir.
why I do not show forces exerted by this body and others. There will be forces like this also. So this is T1, there is no doubt in that. But I don't require. Understood this? So here this is T1 action reaction. This is T3. This is T3. This is T2. We need only this, no? And
Yes,
just
sir.
showing only this part. Because I don't require. Now let us see the requirement is there or not. How many equations are there, man? Two. How many unknowns are there?
3.
3.
3. So can you find 3 unknowns with 2 equations?
No, sir.
No, sir.
It is not possible. Therefore, we need one more equation. Draw the free body diagram of this. If there is requirement, I'll draw now. Otherwise, I don't require. Now, equations are less, but unknown. Unknowns are more. So, what I should do? I should take another free body diagram. This is T3. This is 300 Newton. mg is given directly as 300 Newtons. No? Here, this is also acceleration in zero. No? Sigma Fy is MAY. This is T3 plus minus 300. So what is this? T3 equals 300. Now how many equations are there? 1, 2, 3. Can't you find 3 equations to 3 unknowns?
Yes, sir.
Now you can see I got already T3 is known. From that I can get T2, T1 now. What is T1 then?
Yes, sir.
Sir, screen is not clear.
Screen is clear, sir.
Clear, sir.
This is 5 by 3. What is T3? 300. 500 Newton. Then what about T2? 4 by 5 T1 is T2. 4 by 5, 500 T2. So what is T2? So I got all the 3 things now.
Yes, sir.
Followed. So depending upon the necessity, we'll be showing. Just because we know free body diagrams, we don't show, no.
Yes, sir. Understood.
Whatever necessary, first to take one thing, unknowns are no more, equations are less, draw another one. And all this comes only through your own involvement in practice, man. That's what I'm saying. If you involve only, you learn. The subject is that what I can do. Other subjects, today's topic, you read after 100 years also, it's mugging up on, you know.
Yes, sir.
So return this. Hello. Work completed?
Yes, sir. Completed.
Finished this? Hello?
Yes, finished.
Completed, sir.
Inform,
Completed.
man. Once you complete, please inform.
Then now only completed, sir.
Okay. Now we can see this can be done using Lami's theorem also. Remember?
Yes, sir.
What is that you have? This is 37 means this is 37. 37 plus 90 now. This is 50 till this is 90 now. Do you agree with this?
Yes, sir.
Remember Lami's theorem?
Yes, sir. Remember.
Yes, sir.
If you find out, you'll get the same thing. Anyhow, for T3 you cannot get T3 if you use this one, you know. There is no other go for that.
Sir,
Ah,
in that FPD of hanging mass you wrote na, sir.
pardon? Ah, yes.
In the third one, sir, third equation you wrote na, sir. You said that we should take only particle of one person, sir.
Ah, what did I tell?
Sir, you said show forces acting on this body, sir. Acting on the body.
Ah, yes, on the body only. 300 and this is exerted by earth. This is exerted by string. I showed the same thing, na?
Sir, the 300 Newton is exerted by that. No, sir, correct, only correct, sir, correct, sir, correct.
Can I do?
I'm doing, sir, 1 minute. Done, sir.
Got this? Understood this?
Yes,
Hello?
sir. Got the same, sir. Yes, sir.
Generally, what you'll feel is, sir, this is available now. Why should we do all this bigger one? This is applicable only for
3 forces.
3 forces. That's a disadvantage. Suppose more than 3 are there, we cannot apply this. For example, let us see another situation where there are more than 3 forces. Okay, say this is understood. Hello?
Yes,
Now,
sir.
understood the question now? Right.
Yes, sir.
Now let us show the, here you can see this is one force. I'll take this as first string. Action, reaction. This is T2. I can take like this now. Now
Yes,
this
sir.
is T3. This is T3. This is M1G. Similarly, this is T4. T5. This is T6. Understood? I showed directly all forces. See, previously I showed separately because I have enough confidence now. I am showing directly. Any doubts are there here?
No doubt, sir.
No,
No, sir.
no, sir.
Now here you can see up or not. Actually, here only you can do little bit of confidence you have. No need to show
Lami's
separately.
theorem also we can do now, sir, here.
This is, pardon?
Sir, we can do Lami's theorem by taking those 2 knots different now, sir.
These 4 forces are there, no? 1, 2, 3, 4.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay, there is an additional force here. Okay, this is 1, 2. Do you agree with this or not? 3,
Yes,
4.
sir. Agree, sir.
So this knot is there now. The upper knot you have sigma fx. What are the forces here? Mass into that is a touchdown, you know. Now sigma fy T1 cos 30, any other force minus
Sir,
T3.
T4 also there, na sir, in Excel.
Yes, I am writing that. Plus minus T4 cos 37. Hope you understood this now.
Yes, sir.
Okay, minus,
Sir,
it has
for
its
X,
own weight.
we have
What is the
to
weight of that?
include
T1 is over, T3 is over, T4 is over. Okay,
Sir,
Everything over.
T2
T2,
is over.
sir, T over.
T2 is
Sir,
over.
T2 in over, sir.
Excuse me, sir.
L.
In sigma fx, we have to include the x component of
T4
T4
cos
as well, no, sir.
X component only I have taken. X component only. What have you taken? What are this called? X component only, no?
Sir, X component of T4 you haven't taken in the sigma fx.
We forgot that term.
Yes, sir.
T4 will be like this now.
Sine
T4.
37 degrees, sir.
So you have plus or minus T4
Plus, sir.
sine 37.
Plus.
Understood this? First equation,
Yes, sir.
second equation. Next, come back to this. This is mg. This is T3. So here T3 plus minus 100 is m1.
Zero.
There is no acceleration. Understood this? Clear? Now T4, another 1, 2. How many are there? So count like this: T1, T2, T3, T4. Out of this, T3 is okay. This is over. Now can we get with two equations? These three unknowns cannot be known. Can we know?
Yes, sir.
So again draw for this lower knot. Lower knot. What I am doing is trying to show the same thing on. What is that? For lower knot. You can see that this is 45 means this is also 45 only now. And see, this is 37 means this is 37 only now. I'll write directly sigma fx equals max. So this is T5 cos 45 positive direction. Oppositely you have minus T4 sin 37. Okay, this side. Any other force is there? That's all. Do you agree with this or not?
Agree, sir.
Similarly, sigma Fy equals M2 into Ay. What is Fy you have? T4 cos 37 is upward plus minus T6 plus T5, this is 45 now, cos
Yes, sir.
sin upper one, no? Sin 45, 1, 2, 3 over equals mass of this into acceleration. So this is the other equation. Followed. Now you can take this T6 also you can do. M2G is T6. So T6 equals T6 plus minus M2G is 0. So what is T6 you have? M2G, that is 350 Newton. So you got T6 is over. Please see. We are having how many unknowns? T1, T2, T4, T5, T6. Out of this, the remaining are 4 equations are there or not? Hello?
Yes, sir.
Yes, sir.
This is one equation, 2, 3, 4. You'll find the other unknowns or not? Hello?
Yes, sir.
Understood the free body analysis?
Yes, sir.
Method you followed.
Yes, sir. Understood.
Simple thing, no? See, that's the reason why I just explained what are the forces, different forces. Now, directly I'm using this now. So, when I'm trying to
Yes,
explain
sir.
that fundamental forces and all, you'll get irritated. Why all this? Because that's the building block. So, I have a vision next to what to do, what students require for doing problem. So, that is the reason why my planning will be different. In YouTube's and all, their approach will be different because they are not concentrating on numericals. No? So that is the reason why attend the classes seriously, work out the assignments, get a seat, get out. That's it. Rest all are secondary. Now you can solve these or not?
We can.
Sir, we can
Yes,
solve,
sir.
sir.
Sir, completed.
Understood the method, you understood, Naki.
Yes, sir. Understood.
Return the page.
Yes, sir.
The masses are M1. What are they?
Followed, sir.
See here also. This has a weight. There is a normal reaction. I'll call it as N1. We'll first draw directly all bodies together. It will be easier for us. So this is N1. Do you agree with this? Hello.
Yes, sir.
This is M2G. Understood this or not?
N2. Yes, sir. N2 acting upwards.
This is
N2.
N2. This is N2. And this is M3G.
M3G.
This is the ground. Okay. Now this is
Yes,
M.
sir. N3.
Understood this? And for
Yes, sir.
A, B, C. There is a force on this. Agreed?
Yes,
But
sir.
now if we take this as x-axis and this is positive y, just apply Newton's laws, your problem is solved. For the first body, you have upward N1 plus minus M1G. There is no follow till here.
Lord, sir.
Because there is no acceleration now.
Yes, sir.
Now you can see that for B, N2 plus minus N1 plus minus M2G, there is no force in the x direction. So you have N2 equals N1 plus M2G. N1 is again M1G now. Agreed? And you have sigma Fi is there now. Along F, this is only single force now.
Yes, sir.
There is an acceleration in the x direction. Agreed? So what is the acceleration of this man?
0.
We can do like this. What is the AX? Y0 man?
With respect to
Till here
ground.
is huh?
With respect to ground, na, sir.
Yes, man. With respect to ground, you have to find acceleration. How do you know? Force is there now. This is
Yes,
true.
sir. Yes, sir.
This
Yes,
is true. This is not zero. This is not zero. How it will be zero?
sir. Yes.
At least mass should be zero, no? For this to be zero.
Yes, sir. I didn't see that force.
Right. Now come back to this. You have only forces N3. N2 is nothing but follow this. So you got how many normal reactions? N1 is known. We found N2 also. We found N3 also. Okay, we found acceleration of B is F by M2 along which direction? Any doubt is there? So we got the answers for all three, no? Do you agree with this, boys?
Yes, sir. Sir, accelerations of A and C are zero, no?
There are no accelerations, no A and C, there is no force, no? See, there must be a unbalanced force for the acceleration to exist. Now these bodies cannot go into the ground, no? Can they go into the ground?
No. If there is no force, acceleration.
నేను అనుకున్నాను చెప్దాం అనుకున్నాను టీ పెట్టు అని మరి నీకు హలో
Sir.
Yes, sir.
understood this?
Yes, sir.
I'll send on assignment. Simple things. If you know these things, enough, man. Nothing. It's not a big issue.
Okay, sir.
Only thing you observe to learn physics, you need patience. Agreed. One force is missed, the whole problem will go away. So you'll get sweating.
Then for finding the normal reactions, you should take the only normal forces.
Pardon? I didn't understand. What is that?
For finding the normal reactions, sir, we have to take only that normals, sir, or we have to take all the forces.
Not all the, I have shown all the forces, no? What only normal forces? Contact force is normal
last-
only, no? Normal reactions means these only, N1 only. I didn't get your doubt, man.
No,
I'm
sir,
showing
no, sir, I
all the
got it.
forces.
Yes, sir, I got it.
We should not leave a single force in free body diagram. Because that force also contributes. If you leave a single force, whole problem will go. Now, because in the beginning, as your syllabus progresses, you will see that many forces will come.
Sir,
In here, only gravity. Secondary, you have electrostatic force, magnetic force. So many forces will come.
done, sir.
For till here,
Yes,
right
sir.
then. Go to your mathematics class. Understood till here now? We'll
Yes,
continue
sir.
Sir, understood,
Oh,
sir.
right. Take care then. Don't worry.
Thank you, sir. Bye.
Sir, that test
Thank you,
question
sir.
you said you will show in today's class, sir.
Which one?
I sent in last week, sir.
Yes, sir. Test two things.
That rod of length L.
I'll now solve. What is that you tell? I didn't forget you.
Sir, 1 second. I posted on Dots group. Still, I'll show.
I'll do one thing. Tomorrow morning, the moment class starts, you ask because math class time is over. I don't know math class. Beginning of the class, you ask, and the class commences. Okay. I'll say
Yes,
no.
sir.
Last what we discussed, I'll ask me at that time. You tell that. Okay.
Okay, sir.
Right. Because again, it will be time for other class. No? I had to have some breakfast. You should have.
Okay, sir. Thank you.
Okay, sir.
Bye.
Thank you, sir. Bye.
Bye.